Hello there, I am KP the Math G, and I said from my last video that we're going to do one more table, and I want to just make it simple. I want to do a left and right approximation. There is a difference between this video and the last two videos. In the first of the three, I did a left-right approximation, but delta x was 2 each time. And even when I did the trapezoidal and midpoint, same thing. I had the exact same problem up, really, except I just did one by a different method each time, but delta x was the same. Now, what does it mean to say delta x is the same or not the same? Well, when you look at this table here, let's read it first and then we'll see what's going on here, okay? It says the depth of oil in a tank is given by a differential function h of t, which h stands for height, okay? Where t is in minutes and h of t is in inches. Alright. And so this is the table that we have. Now we're going to get into what delta t is in this particular case. From 0 to 2, delta t is equal to 2. That makes sense, doesn't it? Delta t is always going to be whatever, whatever your base is, and you're always going to do time down here. Alright, and you're going to do inches up here. Okay, and your time in this case is delta t is equal to 2. Alright, you're going from 2 to 6. Alright, this delta right here, delta t is equal to 4. So from 2 to 6, delta t is equal to 4. Alright. Okay, and then from 6 to 9, how much is that? Delta t, 9. Alright, we're not going from 6 to 6, going from 6 to 9. That's 3 more, isn't it? Delta t is equal to 3, isn't it? Makes sense, doesn't it? Alright, delta t is equal to 3. Now, let's make that 3 look a little better. Okay. And then from 9 to 15, way over here, delta t is equal to 6, because 6 plus 9 is 15. 3 plus 6 is 9. 6 plus 3 is 9. 2 plus 4 is 6. 0 plus 2 is 2. Okay? So right here, delta t is equal to 6. And we have to use those 4 numbers, whether we're doing a left approximation, whether we do a right approximation, whether we do a trapezoidal, or whether we do a midpoint. We still need to keep these in mind. Okay? Alright, let's erase this. Remember now, too, that when you are doing this, especially on your AP exam, if you're taking an AP class and you're doing a left approximation, you need to know where you're going from 0 to 15. That's in terms of time. You put your time here. And h of t dt. That's what you do. and it's approximately equal to. If you don't have this, they're not going to know that you understand what we're talking about or what you're talking about. Okay, so let's do the left approximation. Now remember, we're starting from the left. This is F at t. F at 0, alright, is 4. Alright, so we're going to look at that in just a moment. Okay, we're looking from the left, and we're not going to worry about the right one. Okay, left is left. Alright, F at 2, F at 6, F at 9. Okay, when we do the right one, I like to just start from the right and leave off the left one. And any way you want to do it, but you still got to leave one of them off. We're only concerned about these 4 here. Alright, so let's see. F at 0. Alright, so let's see. We're going to say, and I wrote this down. Okay. Okay, so we're going to say F at 0 is 4. Okay. Yep. Yeah, 4. Let me get this right here to use this. So 4 times the first delta t is 2. Use the first one. Okay, see that? Plus the next one is F at 2, which is 9. So 9 times the second delta t is 4. Alright, plus F at 6, alright, which is 16. The third delta t is 3. Alright, plus F at 9, which is 20. So 20. And the fourth delta t is 6. And you're going to do that whether you're doing left or right. 2, 4, 3, 6. Okay? You're going to do that. Alright, now let's figure out what this is equal to. Alright? Always you're approximating, but this answer is exact, so you can still put equals. Okay? And you're making an approximation, so you have to say this here, but this answer here is equal to. 4 times 2 is 8. 4 times 9 is 36. 16 times 3 is 48. 20 times 6 is 120. So when we add those 4 up, I want to say we get 212. 8 plus 36 is 44. 44 plus 48. 4 and 8 is 12. 4 and 4 is 8, and 1 is 9. Did I get 92? Yes, I did. And then 92 plus 120. Alright, that's equal to 2. 9 and 2 is 11. Carry 1. And then 1 plus 1 is 2. I think 212. Alright, that's right. Now, what did you find? If they want the amount. Now, remember in the other videos we had to find the average. The average temperature, I think that's what we were talking about last time. In this case, we're looking at the average number of inches. Okay, in this case, we're looking at inches. 212 inches. Alright, we're not looking for the average. If we had average, it would be 1 over, if we had average, this would be 1 over 15 minus 0 is 15. We're looking for average. And then we take this answer and divide by 15, which if we did that, okay, I've got a calculator right here. Alright, so 212 divided by 15, that would be average. That's average about 14.133333. Okay. All right. So a little over 14 inches if you're taking an average. Okay. But we're not. We're looking at total amount of inches that this oil rolls in the tank. That's what you're talking about. When you have inches and minutes, okay, and you take an antiderivative like we did here, this is a definite integral from 0 to 15. We're looking at this bottom right here, whatever it is, that's what we're looking for. That's inches. So this oil started off, had 4 inches already in there at time t equals 0. But at t equals 15, all the way through, it accumulated up to 212 inches. So left approximation is 212 inches. Alright, we want to do a right approximation. Now watch what I do. I'm going to leave the 2 and the 4 and the 3 and the 6 up there. I'm going to erase these. Okay, look what I do now. Let me get a different color. This will be fine. Now I'm not looking at F at 0. I am looking at F at 2. Let's see. I think I had this in red. I have so many of these pens here. Alright, now I'm looking at F at 15. Alright, this is now the right approximation. So keep in mind, even though I have left here, we've already figured that one out. This one is the right approximation right here. Total amount right here. Total amount. Now, let's put down, we keep these 2, 4, 3, 6. Just keep them there. But now we're looking at F at 2, which is 9. F at 6 is 16. F at 9 is 20. And F at 15 is 29. It's going to be a higher approximation. It's going to be much higher, as a matter of fact. 9 times 2 is 18. Let's put our plus sign a little further out here. 64. 16 times 4. 20 times 3 is 60. Alright, I think that's right. 0, 3, yep, that's right. And then 29 times 6. 29 times 6 is 174. Okay. 6 9s are 54. 6 2s are 18. 8 and 5s, whoa. Is that right? 29 times 6. 6 9s are 54. 2 6s are 12. Yep. 12 plus 5 is 17. Yep. 174. Okay, that's correct. Now, just group whatever you can. I like to see if I could add up to 10, but unfortunately I can't. 8 plus 4 is 12. 6 plus 1, 1 plus 6 is 7. That's 82. 82 plus 60, that's 2. 8 and 6 is 14, 142. Alright, and now this is going to be 2 plus 4 is 6. 2 plus 7 is 14. 4 plus 7, oh, what am I doing? 2 plus 4 is 6. 4 plus 7 is 11. What am I getting at? I don't know. And then 4 plus 7 is 11. Carry 1, 1, 2, 3, 316. So 316 is the right. It's substantially different. So the right approximation is would be 3/16. So you can pretty well guess that if you had to look at the exact amount, since we're making approximations, it's somewhere in between 212 and 3/16. This is an under approximation. This is an over approximation. Alright, so let me show that. Anytime you see how each one of these y values are increasing, so that means that the function itself is increasing. It's an increasing function. Now, I'm not going to just label all this out. I'm just going to show you. It started at 4 and it's constantly increasing. And I don't know, this may jump way up here like this, but it's differentiable, so we know it's continuous. And so if you do a left or right hand side, either way, here's 15 way down here. Alright, so if you do a right side, let me get another color. Let's get something different here. Okay. Alright, especially on the right hand side. Okay, like this, up here, up, somewhere like this. 1, 2, 3, 4. Okay. Alright, and then this one will be up here like this. This will be 0, 2, and I know this is not nearly drawn to scale 2, 6 really, rather 2, 6, 9, and 15. Alright, this is 15 here. Alright, you see that is much. You see all that gap up here where the right hand is? An increasing function, that is, a right hand is always going to be, and I say always, that is correct, it's always going to be an overestimate. This is an overestimate, this is an underestimate, and we've already kind of gone over that before. If you do the left side like this, alright, a left approximation would be more in tune with this. Okay, up here, okay, and then up here, and then up straight across. You have a lot of gap up here like that, and I did this in a previous video. This is definitely an underestimate. Now again, that's because h is increasing. Had it been decreasing, it would have been the other way around. The left would have been an over approximation and the right would have been an under approximation. It depends on the graph. Okay, if this graph is increasing, you can always say the left is going to be too little and the right is going to be too much. Now, if you want to get trapezoidal, you do not even have to do a trapezoidal, all this work if you wanted to do a trapezoidal, because you already have left and right. You can simply say 212 plus 316 divided by 2, and I didn't put this in my notes, but this is true of a trapezoidal. You already know your left and right, and if you know how to do left and right and say, oh, I can't do trapezoidal, I can't remember to do trapezoidal. Well, if it tells you to do left, go ahead and do right. If it tells you to do right, go ahead and do left also. Then you can get this. 2 plus 6 is 8. Alright, 1 plus 1 is 2, and 2 plus 3 is 5. 528 divided by 2. So 528 divided by 2. Alright, so 2 2s are 4. Alright, 2 6s are 12. And 2 4s are 8. So that would be 264. That would be a trapezoidal approximation. Alright, that's the average of the left and the right. I don't even have to do all that figuring. Okay, so that's trapezoidal. Okay. Well, if we wanted to do a midpoint, we could easily do that, but a midpoint you have to add up your, okay, you have to pick, well, 2 from here to here, and then from here to here, and 9. And of course 2, you just got to look at that, and you got to look at your picture a little more carefully there. Okay, I'd have to draw that picture on that one to see, is it 2, is delta x2, or is delta x6? Yeah, that could be that delta x is 6 here, and then here delta x is 9. I'd have to look that up to make sure. Haven't looked at that carefully. I just mainly wanted to get the left and right, and maybe even trapezoidal, and that would be good enough for right now. That's really all I wanted to show, basically left and right, but since I had left and right, I figured we'd go ahead and get trapezoidal. And it's probably going to be somewhere in this area right here. Now remember, if you have to have units, which I have on only one of them, this is in inches, this one is also in inches. Okay, inches and inches. Alright, make sure you put your units there. The height of the oil is that many inches. Okay, that's how you do it. So the next video we're done with approximating now. Okay, you've seen, you can always go back to previous videos, and you can see the left and right one was first, trapezoidal and midpoint were next, and then this one I just decided I would go ahead and do, since these numbers are not a common delta x here, or delta t in this case. Alright, also remember, please subscribe. If you want to, you can subscribe to this, hit that subscribe button, and then also make a comment. KP to MathG, good job, thank you, appreciate you so much, or you could have done this a little better. I don't mind being told that I could be done something a little better, because I want to be at my best for you. After all, I am wearing this name here with pride and dignity. KP the MathG. That's what students gave me, not me myself. I had students to give me this name, and I'm going to wear it with dignity. And for me to do that, I want to be at my best at all times. Alright, this is KP the MathG signing off. Have a great and wonderful day.